Kinematics, the first big topic that we learn in physics. In kinematics, we only look at how a body moves and not about the forces that lead to the motion. Kinematics is relatively simple, so without any further ado, let's get into it. The first level, we have the Suva equations. These equations are the basis of kinematics, and we can use these equations to find initial velocity, final velocity, distance traveled, time, and acceleration. These equations are as basic as we can get. Now, in the second level, we have circular motion. In this type of motion, we use different units for each value, like angular position, velocity, and acceleration. But then, we also have tangential speed and centripetal acceleration, which are a bit more complex, but not too difficult to understand either. We can use the Suva equations here as well. In the third level, we move into two directions and study projectile motion. We now find out that two-dimensional movements are independent in each direction, and we can use Suva or some new equations to be able to find out things like range, maximum height, and flight time of the projectile. In the fourth level, we now use relative motion and reference frames, like being still or on a car with some constant velocity. Here, we can use classical Galilean transformations to go from one reference frame to another, to calculate things like velocity relative to the moving or stationary frame. In the fifth level, we get into harmonic kinetics, which is oscillatory motion without any forces. Even though springs usually involve forces, we can still describe the motion kinematically. Since oscillations follow a predictable pattern, or repeats in predictable periods, we can describe the motion through x of t equals a cos omega t plus phi, which is a cosine wave. Isn't it cool how much math and physics have in common? In the sixth level, we start learning about higher order kinematics, and we start representing velocity and acceleration as the derivatives of position. We get into jerk, snap, and crackle, which are the third, fourth, and fifth derivatives of position respectively. But why do we need to know all this? Well, these values can help us achieve smooth motion where it matters, such as in robotics or vehicle design. The seventh and final level is relativistic kinematics. Here, the speed of the motion gets close to the speed of light. Velocities stop adding normally, and crazily, time becomes elastic? But how? That's because when we get close to the speed of light, Newtonian principles of physics do not really apply, and we cannot use classical kinematic equations. So, we have to start using Lorentz transformations, time dilations, length contraction, velocity addition formulas, 4 vectors describing motion in space-time, and a lot more. Yeah, it's pretty crazy. Kinematics is a beautiful part of physics, and it helps us understand motion without worrying about the forces which create it. If you're a bit confused and want to learn these things at a deeper level, this video is just an overall review. Make sure to subscribe because new in-depth videos are coming soon. Bye!